Exercise 5.3 problem number 6. The points A of minus 5, 4, B of minus 1, minus 2 and C of 5, 2 are the vertices of an isosceles right angled triangle. Where the right angle is at B, find the coordinates of D so that ABCD is a square. The problem belongs to the page number 208. So here they are given the points of A, B and C are the vertices of an isosceles right angled triangle. So we are considering the figure A, B, C is a right angled isosceles triangle. We just mark the points. A as minus 5, 4, B is minus 1, minus 2 and C is 5, 2. Then find the coordinates of D so that ABCD is a square. We just extend two lines from A to D and C to D. If you joining A, B, C, D, you get a square. So you have to find the coordinate of D. So solution, since A, B, C, D is a square, so midpoint of AC is equal to midpoint of BD. So midpoint of AC and midpoint of BD is obviously equal. So we are considering the point D as A, B. So first, this is the formula for midpoint of a line. So midpoint of a line is equal to x1 plus x2 by 2, y1 plus y2 by 2. First, we are going to find the midpoint of AC. So midpoint of AC is equal to, this is AC. So this is a value of x1 plus x2 divided by 2. So minus 5 plus 5 divided by 2, y1 is 4 plus 2 divided by 2. 4 plus 2 divided by 2, which is equal to 0 by 2, 4 plus 2 is 6 by 2, which is nothing but the midpoint of AC is 0, 3. So next, midpoint of BD. So midpoint of BD is equal to x1 plus x2 by 2. So minus 1 plus A divided by 2, minus 2 plus B divided by 2. Minus 2 plus B divided by 2. Already we know that in a square, midpoint of BD is equal to midpoint of AC. So we just going to equate the two coordinates. So midpoint of BD is minus 1 plus A divided by 2, minus 2 plus B divided by 2, which is equal to midpoint of AC is 0, 3. Just equate the x and y coordinates separately. So minus 1 plus A divided by 2 is equal to 0. Minus 2 plus B divided by 2 is equal to 3. Cross multiplication. So minus 1 plus A is equal to 0. The value of A is equal to 1. Similarly, do the cross multiplication. Minus 2 plus B is equal to 6. B is equal to 6 plus 2 is 8. Therefore, the vertices D is 1, 8. Problem number 7 in exercise 5.3. The points A of minus 3, 6, B of 0, 7 and C of 1, 9 are the midpoints of the sides DE, EF and FD of a triangle DEF. Show that the quadrilateral ABCD is a parallelogram. So this problem belongs to same page number 208. So already we see one model problem like this. That is problem number 4 in example 5.3. So up to you are going to find the coordinates of x1, x2 and x3 same like sum number 4. So solution, let D be x1, y1, E be x2, y2 and F be x3, y3 because we doesn't know the vertices of the triangle. Only the midpoints of the triangle are given. That is midpoint of DE is A of minus 3, 6 and midpoint of EF is B 0, 7 Midpoint of DF is C of 1, 9. So midpoint of a line is equal to x1 plus x2 by 2, y1 plus y2 by 2. First, we are taking midpoint of DE. So midpoint of DE is minus 3, 6. This is the formula. So D is x1, y1, D is x1, y1 and E is x2, y2. So minus 3, 6 is equal to x1 plus x2 by 2, y1 plus y2 by 2. Equating the x and y coordinates, we get equation 1 and 2. That is x1 plus x2 by 2 is equal to minus 3. Cross multiplication, x1 plus x2 is equal to minus 6. This is equation number 1. So equating the y coordinates, y1 plus y2 by 2 is equal to 6. If you cross multiply it, you get y1 plus y2 is equal to 12. This is equation number 2. Similarly, next we are going to find the midpoint of EF. Midpoint of EF is equal to x2 plus x3 by 2, y2 plus y3 by 2. Midpoint of EF is 0, 7. So 0, 7 is equal to x2 plus x3 by 2, y2 plus y3 by 2. Equating the x and y coordinates, x2 plus x3 by 2 is equal to 0, which is implies x2 plus x3 is equal to 0. This is equation number 3. Then y2 plus y3 by 2 is equal to 7. If you cross multiply it, you get y2 plus y3 is equal to 14. This is equation number 4. Then midpoint of FD. Midpoint of FD is equal to x1 plus x3 by 2, y1 plus y3 by 2. Midpoint of FD is 1, 9, which is equal to x1 plus x3 by 2, y1 plus y3 by 2. Equating the x and y coordinate, x1 plus x3 by 2 is equal to 1. So x1 plus x3 is equal to 2. This is equation number 5. y1 plus y3 by 2 is equal to 9. So y1 plus y3 is equal to 18. This is equation number 6. The next step is you have to add equation 1, 3 and equation 5. We get 2 times of x1 plus 2 times of x2 plus 2 times of x3 is equal to minus 6 plus 0 plus 2. Because we already know equation 3, equation 5 and also equation 1. So you get 2 times of x1 plus x2 plus x3 is equal to minus 6 plus 2 is minus 4. So x1 plus x2 plus x3 is equal to minus 2. This is equation number 7. From equation 1, this is equation 1, x1 plus x2 is equal to minus 6. Substitute these values in equation 7. We get x1 plus x2 is minus 6 plus x3 is equal to minus 2. So x3 is equal to minus 2 plus 6, x3 is equal to 4. Then equation 3 is x2 plus x3 is equal to 0. Then from equation 7, x1 plus x2 plus x3 value is 0 is equal to minus 2. The value of x1 is minus 2. From equation 5, x1 plus x3 is equal to 2. Then substitute in equation 7, 2 plus x2 is equal to minus 2. So x2 is equal to minus 2 minus 2. So x2 is equal to minus 4. Therefore, we get the value of x1 is equal to minus 2, x2 is equal to minus 4 and x3 is equal to 4. Now, the next step is you have to add equation 2 plus 4 plus 6. So, if you are adding equation 2, 4 and 6, you get 2 times of y1 plus 2 times of y2 plus 2 times of y3 is equal to 12 plus 14 plus 18. So 2 times of y1 plus y2 plus y3 is equal to 12 plus 14 plus 18 is 44. Therefore y1 plus y2 plus y3 is equal to 44 divided by 2 is 22. This is equation number 8. From equation 2. Equation 2 is y1 plus y2 is equal to 12. So 8th equation implies 12 plus y3 is equal to 22. y3 is equal to 22 minus 12. The value of y3 is equal to 11. Then from equation 4, y2 plus y3 is equal to 14. So equation 8 implies y1 plus 14 is equal to 22. So y1 is equal to 22 minus 14. The value of y1 is 22 minus 14 is 8. From sixth equation is y1 plus y3 is equal to 18. So 8th equation implies substitute the values in 8th equation. So y2 plus 18 is equal to 22. y2 is equal to 22 minus 18. The value of y2 is equal to 4. Now we find the value of y1 is equal to 8, y2 is equal to 4 and y3 is equal to 11. Therefore, the vertices D is minus 2, 8, that is x1, y1, and E is minus 4, 4, F is 4, 11. Therefore, midpoint of AC is equal to minus 3 plus 1 divided by 2, 6 plus 9. 6 plus 9 divided by 2, which is equal to minus 3 plus 1 by 2 is minus 2 by 2, which is nothing but minus 1, 6 plus 9 is 15 divided by 2. Next one is midpoint of BD. So midpoint of BD is equal to B point is 0, 7 and D is minus 2, 8. So the formula, substitute the values in the formula 0 minus 2 by 2. 0 minus 2 by 2, 7 plus 8 by 2. Now we know about the midpoint formula. So I directly substitute the values in the formula, which is equal to 0 minus 2 is minus 2 divided by 2, 7 plus 8 is 15 divided by 2, which is equal to minus 1, 15 by 2. Now we see midpoint of AC and midpoint of BD both are equal. Therefore, conclusion, midpoint of a diagonal AC is equal to midpoint of a diagonal BD. Therefore, the midpoint of the two diagonals are equal. Therefore, the quadrilateral ABCD is a parallelogram. Problem number 8 in exercise 5.3, last problem of this exercise. A of minus 3, 2, B of 3, 2 and C of minus 3, minus 2 are the vertices of a right triangle right angled at A. Show that the midpoint of the hypotenuse is equidistant from the vertices. So let us consider the figure. ABC is a right angled triangle right angled at A. So A is 90 degree. Then show that the midpoint of the hypotenuse, this is the midpoint of the hypotenuse, we consider it as D, is equidistant from the vertices. This is what we have to show in this question. So solution, this problem belongs to same page number 208. Midpoint of the line is equal to, this is the formula, x1 plus x2 by 2, y1 plus y2 by 2. First we are going to find the midpoint of BC, or otherwise the D coordinate. So midpoint of BC is equal to, x1 value is minus 3, 3. So if you can take like this, CB or BC. So 3 minus 3 divided by 2, 2 minus 2 divided by 2, which is equal to 0 by 2, 0 by 2, which is nothing but 0, 0. So the D coordinate is 0, 0. So we know the distance formula. So distance is equal to root of x2 minus x1 the whole square plus y2 minus y1 the whole square. We have to show the midpoint of the hypotenuse is equidistant from all the vertices. Therefore, first we are taking AD. So, AD is equal to root of 0 minus into minus plus. So, 0 plus 3 the whole square plus 0 minus 2 the whole square. This is x1. This is x1, x2. This is y2, y1. So, which is equal to root of 3 square plus of minus 2 square, which is equal to root of 3 square is 9 plus of minus 2 the whole square is 4, which is equal to root 13. Therefore, AD is equal to root 13 units. Then CD is equal to root of 0 plus 3 the whole square plus 0 plus 2 the whole square, because the D coordinate is 0, 0 and C coordinate is minus 3, minus 2. So, which is equal to root of 3 square plus 2 square is equal to root of 3 square is 9, 2 square is 4. Therefore, CD is also root 13 units. Then BD. So, BD is equal to D is 0, 0 and B is 3, 2. So, root of 0 minus 3 the whole square plus 0 minus 2 the whole square, which is equal to root of minus 3 the whole square plus minus 2 the whole square, which is equal to root of 9 plus 4. BD is equal to root 13. Therefore, midpoint of BC is equidistance from the center. Thank you, students. Up to this problem, exercise 5.3 will be over. We will be meet on the next video, that is exercise 5.4. Thank you, students. Be safe.